All right, everyone, for 3.1, solving systems of equations. Hey, for this one, you guys, in your textbooks, you'll notice that they start you off making tables to solve systems of equations. Then they have you graph them, and then they finish with how to do everything algebraically. Well, in 3.2, you're going to be graphing systems and making tables and that kind of stuff. So I'm going to save that for later. Okay, so for today, we're just going to look, for 3.1, we're just going to look at how to do the algebra for solving systems of equations. Now, we did this in Algebra 1. Let me just give a brief background on what this is all about. Okay, so for 3.1, when we are solving systems of equations, I want you to keep this in the back of your mind. We're going to be doing linear equations at this point. Take pre-calc and we'll do solving systems with quadratics. Actually, we might do a little bit of that later on, but not as much as we do in pre-calc. But anyway, if we have lines, okay, so if I have two lines, like in a system of equations, and you might be asking yourself, when in the real world do you have systems of equations? Well, there's a couple of real-world examples that you'll see in your homework. There's definitely one always in the first part of your chapter. But anytime that we have, so in business a lot, we want to look at like what our costs are versus like what our income is. And we want to know like a place where we have what we call the break-even point. So I think that's what your introduction real-world problem is about. But if we had one line that is talking about cost and one line that is talking about income, the place where the two graphs cross, okay, so if we're talking about costs, perhaps our cost is doing something like this over time, and then hopefully our income is doing something like this over time. Okay, the place where those two things cross, that's called the break-even point, and it is also called, for in math purposes, that is called the solution to the system. So up until this point, you guys, with lines, what we've done before is we've always said the place where we have a crossing on the x is the solution. So if I had a line like this, if I looked at this place right here, that would be the solution to the line. Okay, now we're moving on to say the solution in a system is the place where the two lines cross. Okay, so if there was an equation for this guy and a different equation for this guy, the only solution, okay, so if you're talking about an xy equation, right? So y is equal to some kind of version of this. That's the parent function. But the only solution to both equations, all right, is going to be this place where it crosses. That's the only x, y coordinate that will work with both equations. That is the solution to a system. So knowing that, we're going to cruise down here to two methods, and we've talked about these before, I believe, in Algebra 1, but we're going to bring them back here. Two methods to solving a system algebraically. One is what we call the substitution method, and the other is called the elimination method. So for substitution, what we're going to do is we're going to solve one of the equations for one variable. Okay, so what that means is if I have like 2x plus 3y equals 6, I'm going to solve for one of the variables. Perhaps I solve for x, right? So then I would have 2x is equal to negative 3y plus 6, and then x is equal to negative 3/2 y plus 3. So you solve for one variable. It doesn't matter which one. That's the first step. Then what we're going to do, and that's in one of the equations. So there'll be another equation probably here like x plus y equals 1. What we're going to do next is we're going to take this and we're going to substitute it in to the other equation and replace the variable that is there. So instead of saying x plus y equals 1, we're going to replace the x part with this part that we came up with in step 1. So it would look like this, negative 3/2 y plus 3 plus y equals 1. I just substituted all of this guy in for x in my other equation. Okay, so that's called a substitution. Now that I'm down to one variable, I can combine like terms and actually solve this, all right, which I'm not going to do here, but we'll see that in the next thing. But that's essentially what we're doing with the substitution method. So let's look at this, you guys. Substitution. Typically, the reason that you would use a substitution is if you have a variable by itself. Otherwise, you're probably going to be looking to eliminate. Most students prefer to eliminate versus substitute, and that's okay, but you do need to learn both. All right, so what I like to do is I always like to find the easiest thing to solve for. Typically, that is a variable by itself, and in this case, it is this y. Okay, so I'm going to solve the second equation for y by moving the 2x over. So y would be equal to, if I subtract 2x from both sides, negative 2x plus 7. Now again, the strategy is take this and we're going to substitute it in for y because y is equal to that. So we're going to take it and we're going to substitute it into the other equation. Very important that we're going into the other equation because we got to see where the two have overlap. Okay, so we're going into the other one. All right, so here we go. Let's plug it in. So we have 5x minus, and then we're going to, well, let's do this, minus 3. We're going to use parentheses times negative 2x plus 7. Always use parentheses equals 23. Okay, then we're going to simplify this out. So we have 5x, negative 3 times negative 2x is positive 6x. Negative 3 times 7 is negative 21. Okay, so I'm just distributing it out. And then let's solve this. So I'm going to add 21 to both sides. Combine my like terms there. This becomes 11x. This goes away. This is 44. If I divide both sides by 11 to get x by itself, I get x is equal to 4. Okay, now that I have x is equal to 4, I have to figure out what the y value is, okay, because your solution is going to be an x, y coordinate. So I'm going to take this x value, and you can plug it back into either equation that you want. I'm going to plug it back into the first one because it looks a little easier. All right, so I'm going to do 2 times 4. I substituted the 4 in for x. 2 times 4 plus y is equal to 7. That's 8 plus y is equal to 7. Okay, so if I subtract 8 from both sides, I get y is equal to negative 1. So my coordinate here would be 4 comma negative 1, and I'm done. What this is saying is if you want to test yourself is if you plug a 4 in for x in both and plug a negative 1 in for y for both, that should work in the problem. So if you plug that 4 back into the first one, you'd have 5 times 4, which is 20, minus 3 times negative 1, which is negative 3. So 20 minus negative 3 gives you 20 plus 3, which is 23. So I just checked that in my head. If you plug this into the other one, you'd get 2 times 4, which is 8, minus 1, which is 7. That does equal 7. I checked it. This is the only solution to that system. All right, so let's try this again with this one. For this one, I'm going to solve for this x. So I'm going to have x is equal to positive 7y plus 11. I'm going to take that and plug it in for this x. So 5 times 7y plus 11 plus 4y equals negative 23. All right, so now I'm going to solve this. I don't know why I put that parentheses there. There we go. Now I'm going to solve this, so I'm going to distribute it out. So I get 35y plus 55 plus 4y equals negative 23. Okay, combine my terms there. I'm going to have 39y plus 55 equals negative 23. Subtract 55 from both sides, and I get, what is that, negative 78 equals 39y. And I believe if you divide both sides by 39, you get y is equal to negative 2. Okay, now that I know that, I can plug that back in. So if I plug that back into the first equation, what I will get there is x minus 7 times negative 2 equals 11, which is x plus 14 equals 11. Therefore, x is equal to -3 when I subtract 14 from both sides. All right, so my solution to the problem, -3, -2. So that is an example of substitution. And that'll be example 4. So for your example 4 homework, and I'm only going to give you example 4 and 5 homework for this. For example 4, you're just solving for one variable, plugging that thing back into the other equation, solving for that single variable, plugging that back in, and that is your solution. If that was all confusing, refer to the key concept, step 1, 2, 3. So that's substitution. All right, hopefully that is making sense. For elimination now, for elimination, the big idea is that we're trying to get rid of one of the variables in order to do the same thing we did here, get one variable in the equation. The goal is to just get one variable. So what we're going to do is we're going to multiply one or both equations by a number to result in two equations that contain opposite terms. What does that mean? That means if I have something like this, 2x plus 3y equals 6, I think I did that in the last one, and I have, let's just keep the last one the same, something like that. If you want to eliminate one of the x's or the y's, what you have to do is you have to make them match up. So again, in algebra, as long as we do the same thing to both sides of an equation, it's legal to do, right? It'll still mean the same thing. So if I wanted to get these x terms to be the same, maybe I want them both to be 2x, okay? What I can do is I can multiply this whole second equation by 2. So if I do that, this becomes 2x plus 2y equals 2. I multiply everything by 2. Once you do that, what they want you to do is, here they say to get opposite terms. It doesn't really matter if they're opposite. Just try to get the terms to be like the same. If they're opposite signs, that's fine too. If the signs are the same, what we're trying to do is we're trying to eliminate these. So to eliminate them, we would have to subtract. Okay, because we're trying to get the x's to go away. If we added them, we get 4x. If we subtract them, we get nothing. So if we subtract, we have to subtract everything. Okay, so this would go away. 3 minus 2 is 1y. 6 minus 2 is 4. So I would be left with y equals 4. All right, and then I would do the same thing that I did in the last one. I could take this 4 and plug it back into either of my equations and get my x. All right, so that's step 3 there. So elimination looks like that. To start you off, in example 5, they match up the stuff for you, which is nice. So here, what I mean by that is they match up something to eliminate, so you don't have to do any multiplication like I did in the first one, right? But I'll show you how to do both. So here, we see that the y's line up. Okay, and if the things aren't lined up, like if this is out of order, just make sure that you like algebraically move things around so the x's are lined up and the y's are lined up, all right? But here we have the y's lined up, and we have -3 plus 3. If you add those two together, we know that those go away. So I'm going to add the whole thing together. 4 plus 2 is 6x. -3 plus 3, positive 3, is 0. So this goes away. That's the goal of elimination. We eliminated y. Okay, and then for -22 plus 16, I get, I believe I get -6 for that. Okay, so here we're going to divide both sides by 6, and we get x is equal to -1. Okay, now that I have x is equal to -1, I can plug it back in. I'm going to plug it back into that guy. So 2 times -1 plus 3y is equal to 16. This is -2 plus 3y equals 16. Add 2 to both sides, I get 3y is equal to 18. Therefore, y is equal to 6. So solution, x, sorry, not x. Let's just do the xy coordinate. -1, 6. All right, if you graph these on Desmos, you guys, you should see that these two graphs cross right there at -1, 6. Let's do another one. So here, for this one, the signs are the same. Whenever the signs are the same, we're going to subtract, right? Because -5 minus -5 is -5 plus 5, so that would make this go away. So here we're subtracting. 6 minus 4 is 2x. Negative 8 minus negative 12 is negative 8 plus 12, which is 4. Okay, then we have x is 2. Plug that thing back in. I'll plug it back into this one. We get 4 times 2 minus 5y equals negative 12, which is 8 minus 5y equals negative 12. Subtract 8 from both sides, you get negative 5y is equal to negative 20. So y is equal to positive 4. Negative 20 divided by negative 5 is positive 4. So the solution to the second one here would be 2, 4. Okay, so that's example 5, where we're solving by elimination. For example 6, which I think you'll have a couple of these mixed in, what we're going to do is we're going to do the exact same thing, but I'm going to show you what it looks like when there's no solution or there's infinite solutions. Okay, so let's look at this one. First of all, what we got to do with this one is we have to get something to line up. So notice with this one, we can multiply, I would like to multiply this first one here by 2 because I want to try to eliminate a's. So I'm going to rewrite the first one as, if I multiply everything by 2, 18a minus 14b equals 28. The second one I'm just going to keep the same. Negative 18a plus 14b equals negative 28. Okay, I was trying to eliminate my a's, so I'm going to add because they're different signs. Okay, so these go away. But notice here that also the b's go away. Negative 14 plus 14 leaves me with 0 as well. So on this side, I'm left with 0. And then 28 plus negative 28 is also equal to 0. Okay, so for example 6 here, on the first example, we have a 0 equals 0. Whenever 0 equals 0, you ask yourself, how often does that happen? It happens all the time, right? This is always a true statement. If it's always a true statement, this is an example of infinite solutions. Okay, whenever you solve and you get something like 0 equals 0, it's infinite solutions. Which also means that, you know, this thing is going, if it's infinite solutions, it's going to be the exact same line, right? There's no intersection. It was just the same line on top of itself, like the line graphed over itself. So anything on the line works. So that's what's happening graphically. Let's look at this one. For this one, so now this one's a good one to talk about. So you guys pay close attention here. For this one, I can't just multiply one equation by something to get something to line up with the second one, right, in order to eliminate. So what I'm going to do is I'm going to try to find a common number that both of these go into. And right off the bat, the one that I think of is 30. Okay, so I'm trying to get both of those to be 30 so that I can eliminate. So what I have to do is I have to multiply this one by 5 and multiply this equation by 6. So let's go ahead and rewrite those out now. So I multiply the first one by 5, I get negative 30c plus, what is that, 60d equals 81 times 5. 80 times 5 is 400. 5 times 1 is 5. So I'm guessing that that would be 405. Okay, and then for our second one, let's go ahead and multiply by 6. So I would get negative 30c plus 60d is equal to, same kind of deal here, this would be 366, I believe, but this would be negative, right? So negative 366. And now I can eliminate. Okay, the signs are the same on my c's, so I'm going to add. All right, so, sorry, not add. Whenever the signs are the same, we're going to subtract. Negative 30 minus negative 30 would be negative 30 plus 30, which makes this go away, right? And then 60 minus 60, that goes away as well. So I'm left with 0 on this side, but notice what happens on the other side. 405 minus negative 366 is going to be, what? I think that's going to, we're going to add, so it'll be 771 or something like that. Doesn't really matter what it is. This is never a true statement. 0 is never equal to that. So the answer to this one is no solution. So the difference between them, if you get something that is true always, infinite solutions, right? Where like things cancel and you just get 0 equals 0 or something like that. When you get something that is always false, the answer is no solution. So these two lines will never cross, which means, if they're x, y, if you had this, if this was talking about x and y, which it doesn't really matter what the variable is, but your slopes, you could solve each one of these. What you'd find is the slopes would be the same with different y-intercepts. These are parallel lines, right? Parallel lines never cross. Therefore, there's no solution to those things. All right, guys, that's it for this one. Again, the homework will be a little bit modified on your homework